So our last speaker is Kendra Oudyk. And Kendra will provide us with a comprehensive introduction to Git, which I think is useful for everyone, no matter how much time you spend coding. I think it's, as well as was shown on other talks, it's very useful for version control and many other things. Kendra recently defended her PhD in neuroscience at McGill University, specializing in meta-research to enhance research practices and reproducibility in the field. Her work uses text mining to explore scientific literature, aiming to understand and improve how research is conducted and disseminated. Kendra also co-founded the Open Science Office Hours, a community-driven initiative at the Neuro that supports researchers in adopting open science practices. She is passionate about the intersection of neuroscience, data science, and research transparency. Kendra is dedicated to developing scalable, accessible tools to foster a more open and reliable scientific ecosystem. She's also passionate about teaching and is a certified instructor with the carpentries. So Kendra, I hope the screen sharing works now. If you're ready, feel free to now share your screen.
We cannot hear you, just so you know.
Yeah, I just turned on my mic. Can you see my screen and see me now?
Yes, perfect.
Okay, perfect. Hi, everyone. Again, I'm introducing Git today, and I just want to note that a lot of this presentation has been based on these two really great resources. And actually, if you want to set up Git on your own computer, I'm not going to go over that today because it's different depending on what operating system you're on. But if you go to the Software Carpentries website and look up Git, there's a whole list of instructions for installing on different operating systems and getting started. I don't encourage you to do that right now because it'll be hard to listen and do that at the same time. So first of all, why should we use Git? I think this is a situation many of us can relate to where we try to do our own kind of version control, but as many of you have probably experienced, it's really hard to actually keep track of what was done in which revision, and going back can be challenging. So Git helps with that through distributed version control, and I'll explain what that is first. Then I'll talk about how to track your own work with Git, and then how to share your work and collaborate on GitHub. Oh, and actually, just quickly for the panelists, how long do I have? Because I know we're running behind.
It's still 25 minutes for your talk.
Okay, thanks. Oops. So distributed version control is where, say on your computer, you have a file you're working on, but you also have a version database with all different versions of the file. And that entire system is mirrored on someone else's computer who you're collaborating with. And it's shared through this common, either a server computer or through GitHub, where the entire version history lives in each place. And this makes it really easy to go back in history and to collaborate on work. So first of all, Git versus GitHub is a little confusing. Git is the language that we use to do version control, and GitHub hosts the repositories online. So this box here could be GitHub, could be Bitbucket or GitLab, or a server computer, could be anything that links more than one computer from individuals working on something tracked with Git. So now how to track your own work with Git. We'll cover most of these commands, but don't get overwhelmed, because to start, you only really need a few commands. And honestly, when I started for the first few months, I just used these 4 commands. So first, we'll talk about how to get help. So first of all, in the terminal, if you know the verb and you want to know what it does, you can just type in git help and then a verb. So for example, git add. And then it shows you the name, it shows you different options you can use, and it has a description. And just a tip, to exit that, you use Q. And really just look it up. You can see that even though I've been using Git for years, I've still recently looked up Git undo last commit. I like to look things up just to make sure I don't do something wrong. So first of all, starting a Git repo. There are two options. You can clone an existing repo from GitHub, so that's represented here. So there's the cloud, basically, which is wherever the remote repo is, and you clone that to your own working directory, or you do git init, and that makes the current file folder that you're in a Git repo. So if I just run, git init, and then indicate where with the, this is just a shortcut for the current directory. And then it tells me it initialized an empty Git repository. So now if I do ls, you'll see the folder is empty. If I do ls-a to show all the contents, including the hidden files, it might be a bit hard to see, but there's this folder here called .git. And that's essentially what makes a folder. So this sandbox folder, that's what makes it a Git repository. That's it. So if you delete this folder, then it's no longer a Git repository. So there's a 3-step basic workflow that I'll talk about. And really it is make a change and then add the change and then commit the change. So first you modify a file in your current working tree. So that's represented by this line here. And then you add it by running git add and then the file name. And this is like getting people together to take a picture. You're not actually saving anything yet. You're just putting people, say, on the stage. This is called the index or the staging area. And then finally, you actually take the snapshot. It's like taking a picture using git commit -m and then a short informative commit message. So let's just go over that. I'm going to make a file. I'm going to open VS Code in this directory and start a new file. And I'll just type something in it and I'll save it. And I'll just save it as a text file. So now I have this file in my directory. If I run ls to show the contents of the directory, it's right there. But I haven't tracked it yet, so Git doesn't know it exists yet. So to do that, I do git add and then hello world.txt. And it's now staged these changes for commit. And then if I do git commit -m to add a short commit message, this is actually taking the snapshot. And I want to make sure that I know what I did in this commit so that I can go back in history if I wanted to. So you need to have a informative commit message here. Whoops. And Git is handy. It often actually tells you what you did after you did it, so you can be confident that you know what you've done. And then there's a lot of useful commands that don't actually do anything that you can use as much as you want. And probably the most common one you use is git status. So right now it tells us it's on the main branch and there's nothing to commit. The working tree is clean. That means there's nothing in this working directory that isn't already committed in the local repo. But if I open VS Code again, and change it, and save it, then if I do git status, then it shows that there's one file in my working directory that hasn't yet been staged or committed, or it has been committed, but the changes haven't yet been staged. In order to see what the difference is, you can run git diff and then the name of the file. So you can see that essentially it records it as taking off the first line and adding 2 lines. That's probably because of the new line character, because I pressed enter when we edited it. But here it's showing what the difference is. So if you forget what actually changed, then you can run that. And if you want to see the history of your repo, say to go back in time, you can run git log So this shows that there's one commit, and the commit message is it created hello world.txt. So if I ever do something to this file and I want to undo it back to the original file, then I can go back to this file using this commit hash. And I'll talk about that in a second. So there are a few common undoing goals. So one would be to unmodify a file. So right now I have a file modified, but not staged. So if I want to unmodify a file, I can do git restore and then the file name. So the file's still there, but if I go back to the file now, you'll see that it no longer says I'm Kendra. So basically we just unmodified that file in the working directory. So let's go back and modify it again so that I can show you the next one. So once a change has been staged, and I do that again by doing git add, and I can do status, git status, not just status. You can see that it's been added, so it's ready to be committed. But if I want to undo that, I don't want this included in my next commit, I can do git restore -- staged, and then the file name. Don't worry about remembering all of these commands. You can look up how to do each thing as you need to. It's just good to know what's possible. That's why I'm showing you. And then if I forgot a file in the last commit, I can do git add the file and then git commit -- amend, and it just adds it to the last commit as if it was there originally. Or I can undo the last commit by doing git reset head, and that will put all the changes back as in red. Git status in your working directory. So it would show all the files from the last commit in your working directory. And I've made this in red and this in red because it's possible to permanently lose some information if you run these files. So make sure that you know what the command does. And honestly, undoing feels intimidating at first because you don't want to accidentally lose something. So I have a few suggestions for it. First of all, like I said, don't try to memorize all the commands. Try it on the sandbox repo first. So try it here, do basically the same thing you're doing in your actual repo, and then try to undo and see what happens. Or you can do git checkout and then the commit hash, which you find here when you do git log, and -b and then a branch name, and we'll talk about branches in a second. But basically this starts a new branch at the point you want to revert to in order to see what it would be like if you would revert to that point. And again, this will make sense later when I explain what branches are. For minor recent fixes, you can just use git status because it'll tell you basically. You can use this to restore the file to discard changes in the working directory. So Git is really handy like that. It often tells you what your options are. And another method I sometimes used when I started out, honestly, is I just made a copy of the entire repo and tried the change in the copy and to make sure that it was working the way I expected, and then did it in the real repo if it was working. So that kind of goes around the point of using Git, but when you're starting, don't be afraid to do something like that so you feel comfortable. So now we'll talk about branches. So basically, if you want to see what branch you're on, you can do git branch, and it'll say that I'm on the branch main. So you can see here, this is an old figure, so the principal branch used to be called master, and now it's called main. But conventionally, that's the name of the principal branch where the official version of your code works. So usually whatever is in the main branch is what's working. And then you might have another branch like develop, where you want to develop a new feature or something, and you don't want to merge it into the branch until you know that it works, basically. So you can start a new branch doing get branch and then a name of a new branch, like that. It can be named anything. So if I do get branch, now it shows that I'm on the main branch, but there's also this new branch there. And if you want to change branches, you can do get checkout and then the name of the branch. So now if I do get branch, oops, it shows that now I'm on this new branch. And I could make edits here that won't change what I know is stable and works in the main branch. And then if I want to merge what I did on the new branch into principal branch, so that would be like merging the develop branch into the release branch and then into the master branch, then you do get merge and the branch name. So if you would check out the branch that you want to merge into. So I want main to be have all the changes in it, and then I do get merge and the new branch probably won't do anything because, yeah, it's already up to date because I didn't do any changes in the new branch. And when you're merging branches, you can come across something called merge conflicts. So what if several people edit the same line of code? So imagine this is code and somebody else wanted to say, I like pie here, and I said, I like cake. So how do you decide which change to keep? This is a merge conflict, and someone needs to manually resolve it. So I'm going to give an example here, step by step, of how to create a merge conflict. So hopefully you'll recognize it more easily and be less intimidated by it when it happens. So I'm going to create a file called colors in this current directory, colors.txt, and save it. And on the first line, I'm going to write the word red and save it. Oh, my slides are frozen. Oops. Sorry, my slides are being glitchy for a second here. It's funny, these things always happen when you need to make a presentation or something. I recently did my PhD defense and Zoom stopped working. That was scary. Anyways, I'll keep going with the example and see if my slides decide to behave themselves. So I'm on the main branch again, and I just added this file called colors.txt and put red in the file. So if I do get status, it'll say I'm on the main branch. I have, I have this change that I made to hello world.txt. I'll just get rid of that so it doesn't distract us. So now I have this file called colors.txt that has not been tracked yet. So I can track it with, I can set it up to be tracked with git add colors, .txt. And I can commit it with git commit -m and then a commit message. So now what I'm going to do is check out a different branch, and a little shortcut to both create a branch and check it out at the same time is get checkout -b and then the branch name. Let's see if my slides are working so I can. Nope. Okay, so I'm going to call it new branch. New dash branch, just to be consistent with my slides. And so now I'm on this new branch called new branch, and I'm going to edit the colors text file and add blue. And save it. And here I'm going to commit it on this branch. So git add colors, git commit added blue to colors. And now I'm going to check out the main branch again in order to continue this line of development here. And you'll see that if I go back to the file, that word blue is no longer there, because remember back on the main branch, we only wrote red. So now we're going to write the word green next, so that on the main branch, the second line is green, and on the new branch, the second line is blue. So this is going to make a merge conflict. Hopefully this git add, git commit thing is becoming more familiar to you, because these are the commands you'll use the most. Great. So now say I want to merge this new branch into my current branch. So I'm going to do git merge, and then the new branch name, new branch. And then there's going to be a merge conflict. So if I go into Visual Studio Code, it does this handy thing where it kind of shows you what the merge conflict is and gives you some options. So you can accept the current change, which would be to accept green, which came from the main branch, or accept the incoming change, which would be blue coming from the new branch, or accept both changes. I'm actually curious what this does. When you accept both changes, it puts one on a different line. So yeah, that's how you create and resolve a merge conflict. And you don't have to deal with these a lot when you're just working on your own, but when you're working with other people, you might come across it more often. Okay. Perfect. Okay, so now we'll talk about how to share your work and collaborate on GitHub. So again, this remote could be GitHub, or it could be something else like a server, or GitLab, or Bitbucket. And you can show your remote repos with git remote -v. And right now I don't have any remote repos because it's not associated with a remote on GitHub, so there aren't any yet. But I can add a remote repo manually by doing git remote add and then the remote name. So this is just a shortcut for you, so you don't have to type in the address all the time. So usually the most direct link is stream. Sorry, I'm blanking. I know there's upstream and then origin. Okay, so usually it's git remote add origin. And then the remote address. And if you have something linked further down the line, which we'll talk about in a second, you usually name it upstream. Those are just conventions. You can name it whatever you want, but if you're collaborating people, it can make it easier for them to understand your work. And in order to push commits to a remote repo, you do git push and then the remote name, so probably origin, and then the branch name you want to push. In order to fetch changes from a remote repo, you just do get fetch and then the remote name. And again, to merge, this is how you do it. So here you can see you have the git fetch command, the merge command, and the pull command. And here you have the push command to push to your remote repo. Forks are like a clone, but on GitHub. So remember, cloning a repo was one of the options for starting a repo. But you can make a copy of a repository right on GitHub. And most collaborators on a project will have their own fork where they work, and then they do something called a pull request. in order to merge those changes. So here we have another remote repo, and we have this fork that's made here. So usually your remote repo, again, is called origin, and the other remote repo is called upstream. So then come to a pull request, which is where you push your commits from your own fork to your own fork, and then you open a pull request saying, can you accept these changes into the principal repository? Then the maintainers can review your code, make suggestions, and decide whether to merge it. So that's represented here with pull request. Issues are really important on GitHub. That's where people report problems, propose something new, and find something to work on. So if you want to start collaborating, start contributing to an open project, usually you start by looking at the issues. And that's it. That's how to share your work and collaborate on GitHub. And I just have a few final tips. So again, you can do most of what you need to do on your own, tracking your own work with just these 4 commands. And honestly, you can, I used to just put the commands on a sticky note on my computer, so I didn't have to look it up all the time. And so now I have my acknowledgements. Again, these are really great resources, and I highly suggest going through them at your own pace in order to actually learn it. You don't expect to have learned how to use Git just from this lecture. And that's it. So thank you very much. And I don't know if we have time for questions. I wasn't quite sure when we started, so